Hello again and welcome back. This will be our third video solving past paper questions from the topic photoelectric effect. And in our last two videos, we solved questions targeting these concepts. And in this video, we'll target past paper questions while focusing on graphs. So let's see the questions first, and I want you to see the pattern, okay? It's always nice to predict beforehand what kind of questions you will see in an exam. So if you can predict the question, the type of question that can be asked from a specific topic, it gives you more confidence in exam. So notice this question, the graph, photoelectric effect, and then look at this question, okay? The graphs look similar, right? They are straight line for kinetic energy as a function of frequency. And now we'll ignore this one for the moment and look at this one. Again, it's the same graph, kinetic energy plotted as a function of frequency on x-axis, kinetic energy on y-axis, and the graph is a straight line. Now, there is of course, obvious difference between these straight line graphs, kinetic energy as a function of frequency, and this one, which is drawn for current as a function of potential difference, right? And the other ones were straight line. This one is a curved line. So that's it. These are the only two types of graphs that you can expect in exam. So you just need to understand these both types of graphs. And if you understand both types, then you will be able to answer any question related to graphs from this topic. So we'll first focus on the first type of questions in which you will see a graph in which we plot kinetic energy as a function of frequency. Okay, so I'm talking about this type 1 graph. And the concepts that you need to understand to answer this first type of questions is very simple, actually. You just need two concepts. The first one, so just to again make sure that you remember kinetic energy as a function of frequency. Okay, this is type 1 graph. And the concepts that you need to answer this questions related to this type of graph is, first of all, you need to understand the equation of straight line, because you know that I just showed you the graphs for kinetic energy as a function of frequency is always a straight line, right? So you need to understand the general equation of straight line, which I hope you remember, but let's just do a quick review. Y equals mx plus c, right? Now, if you remember these, what m is and what c is, m is the slope of this line, right? Slope is how steep the line is. And c here is the y-intercept, which means this line, if you extend it, where will it intersect the y-axis? This is the first thing you need to understand. Just remember the equation of straight line, y equals mx plus c, and also understand that m is the slope, c is the y-intercept. And how do you find slope? Finding slope is just y2 minus y1 divided by x2 minus x1. So you basically just pick any 2 points on the line and then look at the y values, y2, y1, and x2 and x1, and use this to find slope, right? The second thing that you need is the photoelectric effect equation. I explained the equation in detail in my last video. Today, we will use that equation to solve graph questions. The equation was that energy of the photon that the electron absorbs is always equal to work function. First of all, electron will use some of this energy HF to break free from the metal surface, and the rest of the energy will appear as kinetic energy of the electron. And this is just conservation of energy. Now, the important thing to note here is that right now, this equation, you see on our graph, we have frequency plotted on x-axis, right? So if you are solving a graph question, you just need to rearrange this equation. What we will do is we will write kinetic energy here, and we'll write HF minus phi. So it's the same equation, just I rearranged it so that for y-axis, we get kinetic energy, and for x, we get frequency. Now, if you understand the equation of straight line, and you also know this equation, photoelectric effect equation, if you just rearrange it for kinetic energy as a function of frequency, you can compare these two equations, right? And if you compare these two equations, you will see that if you calculate slope of this graph, the slope will give you Planck's constant, right? Because F is just x, kinetic energy is plotted on y-axis. So this m must be Planck's constant, h. And similarly, this c, which we called y-intercept, in our case, c is the same thing as work function. So it means if you just extend the graph, read the value on the y-axis, if this is 0, so you will see that the y-intercept will be negative, right? Which you can see here. Y-intercept is negative because you need to put in this much energy to release an electron. So it's kind of a potential well. And that's about it. One tiny detail which you can add to the concepts that you need to solve type 1 graphs is just this. If you look at the graph, you will see that the graph always starts at some value here. It doesn't start from the origin, right? And which makes sense because if we start at the origin, then the y-intercept will be 0, right? Because the graph will be cutting the y-axis at 0, which means the work function will be 0 because y-intercept corresponds to work function. And this cannot be possible, right? Because you always need some energy to release an electron, to break the bonds from the surface and eject an electron. So if the work function is just 0, that means that the electron is already free. It is already ejected from the metal surface. It is just sitting there, which is not what photoelectric effect is, right? Photoelectric effect is you eject an electron from the metal surface. So it must have some work function, and which means that the graph will always start at some positive value of frequency. It will never start from the origin. That's it. These are all the things that you need to answer these questions. Now let's see if you can answer these questions. The first question, as expected, is why are no photoelectrons emitted at frequencies below 4.4 times 10 to the 14 hertz? Basically, what they are asking is what I just explained. You can answer this question in many different ways. You can say that there will always be some energy for work function. And if the graph started at 0, it means that the work function would be 0, which is not possible. But you can also use keywords, which I would recommend you to use. And the keyword you need to use here is called, what we call this minimum frequency, which is required to eject an electron. We call this frequency, it has, some people call it cutoff frequency. So cutoff frequency. Some people also call it threshold frequency. This is the minimum frequency required to start the photoelectric process, which means if you're using a light which is below this frequency, the light will not be powerful enough to overcome the work function, and that's why you will have no photoelectric effect. You can also understand this by just extending this graph on the negative side. So you see, if I extend this on the negative side, and if I also extend this line on the other side, you will see that it cuts the y-axis about here, right? It means this is the energy that we need as work function to release an electron. Now let's pick a frequency below 4.4 times 10 to the 14 hertz. Let's choose this frequency, right? So let's see what is happening at this frequency. At this frequency, our graph represents this point, and this point represents energy of this value. And you can see what it means is that if you use this frequency, the energy of the photon that you are using, energy of the light that you are using, will be this. And you can see this energy is smaller than the work function, the black line, right? And because this energy is smaller than the work function, it means you will have no photoelectrons. So I hope this one was easy. The next question is calculate the work function phi of sodium in electron volts. Now to answer this question, you need the concept that I just explained. You need to compare the equation for photoelectric effect, which was kinetic energy equals HF minus work function, and compare this to equation of straight line, which is y equals mx plus c. And now you know that the y-intercept is actually the work function, right? So you can solve this question in different ways. One kind of a laborious and rough way of solving this question would be to measure this distance with some ruler, or I don't know, and also mark the values on the negative side so that you know that this is, if this is 1 on above 0, this will be -1 below 0, and this will be -2. And then extend this line and see where it cuts the y-axis on the negative side, and just read the value from the graph. And because the y-axis is already marked in electron volts, this will give you a rough value of work function. But there is another way to solve this question. Can you think of another method to solve this question? You can stop the video, try to think of another way to solve this question. I will explain it now. So what you do is you just pick a good frequency point. By good frequency point, I mean the one that has a clear value. So you can pick maybe this 8, which corresponds to this point on the graph, which corresponds to this energy. So what you have now is that you know the frequency, 8 times 10 to the 14 hertz, and you also know the corresponding kinetic energy in electron volts from the graph, which is about 1.5 electron volts. And you can use this here. So F is the frequency, H is Planck's constant. If you multiply the frequency that you selected, 8 times 10 to the 14, whatever, and you also read the kinetic energy from the graph, then it was, I think, 1.5 electron volts. You can just rearrange for work function, but you have to be careful, okay? And you can also see it. This question has 3 marks, which means it's kind of tricky. And the trick is actually in the details, which I have explained in my previous videos. But just to remind you, if you are using hertz as the unit of frequency and you multiply it with h, you will get energy of the photon. This energy of the photon will be in joules. Okay, the energy that you measured on the y-axis for kinetic energy is in electron volts. Now, if you just substitute the values and rearrange for phi, you cannot subtract electron volts from joules or joules from electron volts. So you either need to convert joules to electron volts, or you need to convert electron volts to joules. And since the question asks specifically to calculate work function in electron volts, you need to convert joules into electron volts and then do your calculation. But as an upgrade, as a third upgrade, you can say, there is an even smarter method to solve this question. And that is that we can choose the frequency for which kinetic energy is just 0. We don't want to zoom in and read the kinetic energy on this graph. We'll just pick a point on frequency axis such that the kinetic energy that we get for that point is simply 0. And that point is actually this cutoff frequency, which is given here, 4.4 hertz times 10 to the 14 hertz. And you can see if you choose this point, the kinetic energy for this point is just 0. And choosing this point will actually simplify our equation, right? So if you just put h times 4.4 times 10 to the 14 hertz, so now we have chosen a specific frequency for which the kinetic energy is just 0. And now you can see you just need to rearrange this equation for work function. So phi will be just h times the threshold frequency. Now, this is a useful equation to remember, that if you need to calculate work function, you just need to multiply the threshold frequency with Planck's constant. But you need to be careful. This will be, your answer will be in joules, and you need to convert joules to electron volts, which I have explained in my previous videos. If you don't know, you should watch those videos. Now, the next question, I hope that you will be able to answer this question very easily now. Again, we are given a graph for kinetic energy as a function of frequency. And the question is, add a second line to the graph showing how kinetic energy will vary with frequency for a second metal that has a smaller work function. Now, if you have understood the concept, you know that the work function corresponds to y-intercept, right? So for this graph, the y-intercept is about here. The question asks us to draw a second line for a different metal for which we have a smaller work function, right? So you just need to draw a line that would intercept the y-axis at a smaller value. So maybe just here, you just need to draw a line which would correspond to this y-intercept, which is smaller than the previous one. What about the slope of the line? Can I draw a line like this? It still has the same y-intercept. And the answer is no, because if you remember slope, y equals mx plus c, this slope m was the same thing as Planck's constant, h, right? So because h is just a constant, it means we are not changing h. Planck's constant is just a constant. It means that the slope will not change. So make sure that the line that you draw is parallel to this line. So it will be exactly parallel to this line, and it will look like this. And that's it. Is there another question? Okay, I think I've already explained this part. This is related to the theory of photoelectric effect, and we covered theory in, I think, in our first video on photoelectric effect. And the last question from the first type of graphs is this one. Again, we are given graph kinetic energy as a function of frequency, and the question is, use the graph to find Planck's constant, the value of Planck constant. Now, I don't think I need to explain this question. You already know how to solve it. Just pick 2 points. The only tip I can give you is to choose 2 points that have a well-defined value. So maybe, for example, this point, this is 90, and here it is about, okay, maybe this is not a good point, but maybe this is a good point. Yes, this is 70, and here you get a clean intercept of 1, right? And the second point can be just this origin, but this again is not a good point. Okay, maybe it is. You just need to count the number of spirits. You know how to calculate slopes, right? Just pick 2 points and then do y2 minus y1 divided by x2 minus x1, and you will get the value of Planck's constant. Another important thing, sometimes if they are like really evil, what they will do is they will give you this energy of kinetic energy in the units of electron volts, right? And if you use electron volts and divide it by frequency, which is in hertz, you will not get the right units for Planck's constant, which is h. H has units of joules into seconds, so joules times seconds. And if you use, for example, electron volts, then you will have electron volts times seconds. So you will not get the usual value for Planck's constant that we see. And this just confuses some students. They think that maybe they used the wrong equation or something. So you have to be careful with units. Always, units can help you a lot. They can also sometimes help you solve the whole question. You just need to get the units right. For example, even if you didn't know that slope corresponds to Planck's constant, but you knew the units of Planck's constant, you can guess that somehow I need to divide this energy on frequency and I will get the units of Planck's constant. So this can give you some idea on how to solve questions. Always be careful with units, okay? The next part of this question is, use the graph to find the work function of sodium metal. And again, this is very easy. We just need to choose a frequency for which the kinetic energy is just 0. We also call it threshold frequency, which is this. And we will multiply this frequency with Planck's constant h, and this will give us phi. This is work function. And the next question is, calculate the stopping potential when the frequency of the incident radiation is this. Now, at this point, if you haven't watched my previous video in which I explained in detail what stopping potential is, if you haven't watched it, it's really important that you watch that video first, because for this question, I think you will not understand what I'm saying if you don't understand the stopping potential. And that's why I didn't explain stopping potential at the start of this video, because I'm assuming that you have watched the whole series, all the 3 videos. So you know that in order to stop the electron from reaching the other plate and to get 0 current, we apply negative potential, which we call stopping potential. And what stopping potential does is it just balances the kinetic energy of the electron. So the electron is moving from one plate. It has some kinetic energy and it is moving towards this plate, and we are trying to stop it. So how can we stop it? We need to apply some potential energy to cancel this kinetic energy, right? And since we apply the potential energy in the opposite direction, this one is positive and this one is negative. So this positive plate is kind of attracting the electron. So you can see that it's trying to stop it. We call this potential stopping potential. But the energy that this stopping potential creates the stopping potential energy, is given by E times V. So you need to be careful. If you multiply E with V, I also explained this in my last video, this now is the stopping potential energy. This is not stopping potential. This V is stopping potential, okay? What is E? E is just the electronic charge, the charge on an electron. So you just multiply charge on an electron with the potential, you get potential energy. And we need to balance this kinetic energy, So it means that the stopping potential energy must be equal to kinetic energy. That's the only way you can stop the electron. If your potential energy is smaller than the kinetic energy, then the electron will reach this plate and you will get some current here in the ammeter. So if they are equal, then the kinetic energy is balanced and all the electrons will be stopped and you will get zero current. This potential is the potential that they are asking us to calculate. So what we need is, we need to first calculate kinetic energy of the electron. How can we calculate kinetic energy? They have given us the frequency. So we can just read the kinetic energy from this graph, right? So the energy that they have given us, frequency, is 9 times 10 to the 14 hertz. So you just pick this point, this one, which is 9 times whatever, times 10 to the 14, and you can read the energy, that kinetic energy corresponding to this this frequency, sorry. And this is the energy that you see. I don't know, this is 2, yeah. So you can just read it, whatever this energy is. I don't know, 2.2, maybe 2.1, whatever. This is in joules, so we don't have to worry about the units. Everything is good. And just substitute it here. So the kinetic energy is 2 point something, and joules should be equal to potential energy, which is E times the stopping potential V. Now you have to, the question is not asking you to find the potential energy. They just want the stopping potential. So you need to divide both sides by the electronic charge. It will cancel on the left side, and on the right side you can just divide this number by the charge of electron. So 2 point something divided by the charge on electron, which is 1.6 times 10 to the negative 19 coulombs. And joules per coulombs will give you the units of volts, okay, which is the right unit for stopping potential. Now the next type of graph, this one, you can see, first of all, it is different. So again, we need to kind of generalize these graphs, right? The second type, what can we expect for this second type of graph? So the first thing, how can you recognize the second type of graph? It will be current on y-axis and voltage on x-axis. This graph can have two different types. It can be plotted for different intensities, and it can also be plotted for different frequencies. Now let me explain what it means. So if you just plot current as a function of voltage, so let's focus on the first type, okay? Current versus voltage for different intensities. The question that we will solve today in the past papers, actually it's simple. It's none of these types. It's much simple because intensity and frequency will be constant. So but I just, for completeness, I will cover these because there will be some other questions which might test you on your understanding of these two subtypes, okay? So first, different intensities. How can we understand? A lot of students get confused by this word intensity. They ask, oh, what is intensity of light? Intensity is just the brightness of light. So if you have one light bulb, you have low intensity. If you have 10 light bulbs, you have high intensity, okay? And what is the effect of intensity, increasing the intensity in our photoelectric effect experiment? If you increase the intensity, the only thing that will change is the number of electrons that are emitted per second. Okay, you have to listen carefully. It will only change, it will only increase the number of electrons emitted per second. It will not change how fast the electrons move. It will not change the kinetic energy of the electrons. It will just change the number of electrons. And what is current? Current basically is just charge per unit time, right? So if you are getting more electrons per second by increasing the brightness, it means you should get more current, right? So any graph that you see in which you have three different lines and they have different values of current on y-axis, let's say like this, another line like this, and another line, let's say like this, you should understand that these three lines are representing different intensities, okay? Because we know that different intensities change the value of current. So this is low intensity I1, this is a bit higher intensity I2, this is the highest intensity I3. So the highest intensity will correspond to the highest current. Another thing that I want you to notice here is that they all start at the same point on the negative potential axis. And we just discussed negative potential actually tells you what is the kinetic energy of the electron, because from negative potential, what you can calculate the stopping potential energy. And we know that stopping potential energy, in order to stop the electrons, stopping potential energy must balance the kinetic energy. It means that all of these three lines, the electrons that are emitted, they will all have the same kinetic energy because they have the same stopping potential. So, in summary, for current versus voltage graph, if you see different lines plotted on current axis, all of these three lines, for all of these three lines, the kinetic energy or the speed of the electrons will be the same, okay? They will have the same kinetic energy. They will all start at the same point on the negative potential axis, but they will have different intercepts on the current axis. And the reason is that because intensity depends on current depends on intensity. Now, the second type of graph for different frequencies will look different. How will it look like? uh, I will ask you to stop the video and think about it for a minute and see if you can get the right answer. Now this time we will plot three different lines representing three different frequencies. And if we change the frequency, what happens actually? If we change the frequency, the kinetic energy of the emitted electron will change, right? Because we know that HF equals kinetic energy plus work function. So work function, let's say it's 2. Now if you increase, and let's say initially HF was 10 units, so kinetic energy must be 8, right? Now if I increase frequency, let's say 10 to 20, and keeping the potential keeping the work function constant, now kinetic energy will be 18 because the electron has more energy to use as its kinetic energy, because work function is the same. We are using the same metal, but we are using a higher frequency. So after absorbing this photon, the electron will have a lot of extra energy. So it will use this energy as its kinetic energy. So this thing is very clear that increasing the frequency, the kinetic energy of the electron will increase. That's also what we saw in the graph. Kinetic energy as a function of frequency is a straight line. Higher frequency means higher kinetic energy. So it means if you increase the kinetic energy by increasing the frequency, you should get different values of stopping potential, right? So now the three lines that I will draw will have different stopping potentials because they have different kinetic energies, because we are using different frequencies. So first line will look like this. If we increase the energy, we need more a higher stopping potential to stop it, then it will look like this. And another one, if you again increase the frequency, it will increase the kinetic energy and you will need more higher stopping potential to stop it, and it will look something like this. Now the thing to note in this graph is that all of these three lines will have about the same intercept on current axis, which means the frequency has nothing to do with the current in the photoelectric effect. Frequency just means how fast the electrons move, right? It is not the number, it has no effect on the number of electrons that are emitted. The number of electrons that are emitted uh, is influenced by intensity, not frequency. So just remember these two graphs, okay? The one in which you get different values for x-intercept, so different stopping potentials, negative V1, negative V2, negative V3. It means that this pink or purple line is representing the photons with highest frequency, because the electrons that will be emitted as a result of using this light will have higher kinetic energy, and that's why we need higher stopping potential to stop those electrons. And they will all have the same current because we are not we are not changing the brightness of these lights. The brightness is constant. So if you now understand the second type of graph, uh, you can answer any question basically from the graphs, because that's it. These are all the possible graphs that they can test you on, right? So for example, this graph, the question is, first mark a letter S on the graph to show the stopping potential. So the first question is very simple. This is the stopping potential. We just have to mark it. The second question is, the photocathode is replaced with one whose metal surface has a greater work function. Okay, so it means we are increasing this phi. On the graph above, sketch how I would vary with V given that the wavelength and intensity of the incident radiation remain unchanged. Again, like I explained, that the question that we will solve, in that question, we will keep the frequency and intensity constant. So wavelength is related to frequency. If they are saying that the wavelength is constant, it means frequency is constant and intensity is also constant. So if you keep the frequency and intensity constant, you just get one line, right? You will not get three different lines. That's why this question is much simple than what I explained here. But like I said, you can also expect possible questions from these graphs. So you should understand these graphs also. Now coming back to our question, wavelength and intensity is constant. The only thing that we are changing is this work function. So let's see what it means. So we have HF, energy of the photon that the electron absorbs. It will use some of this energy as work function. The remaining energy will be kinetic energy of the electron. Now, if I'm increasing this work function, right? Remember, first thing, that this equation is not for this graph, okay? I've already explained that this equation is a linear equation. The graph for this equation will be a straight line. This is a completely different graph, but still you can get some information on how the graph for I as a function of potential will look like if we change the work function. And in order to see how the graph will change, we need to look at this equation. I didn't write this equation because this equation represents this graph. So what can we extract? What kind of information can we extract if we change this work function? Let's do an example. So if, let's say, initially the photon energy was 10 units, and let's say work function was just 2, kinetic energy we know must be 8, right? Because they have to add, it's just conservation of energy. Now the second, like the question says, if we change the work function, if we increase the work function, let's see what happens. And the question says that wavelength, which is related to frequency, and intensity is constant. So which means we don't have to change anything else. So we still have HF. This is the first case. Now in the second case, we are still using the same photon, same frequency, same wavelength, and the work function has increased, right? Because we are using a different method. So let's make it 4 this time. What should be the kinetic energy? This time the kinetic energy will reduce. It will be 6. So now you kind of understand what the question is about, right? The question is that if you increase the work function, the kinetic energy that you have will be smaller. Now, how can you represent a smaller kinetic energy on this graph? So if you understood my very long explanation a minute ago, you know that you can represent a lower kinetic energy on this graph as a lower stopping potential, because the kinetic energy is smaller. Now it means that we need a smaller stopping potential to stop it. So it means that the graph will look exactly like this one, but it has to start with a smaller value of stopping potential. So the graph will look something like this. That's it. And you get 3 marks for this question. So you see, if you understand all the concepts related to a specific type of question, this gives you confidence and also saves a lot of time. You don't have to think in the exam, because you have already thought all the possible questions that they can ask, right? And in the exam, if you see a question, you just know how to solve it. So again, like I always say, make sure you cover all the different aspects of a single topic before moving to the next one, because that's the only way to get that confidence that you need in exams. Best of luck.